We're going to jump into the 214 focus lesson here. And our I can statement is to be able to find equivalent ratios and graph them on a coordinate grid. So we're going to have to do some graphing today with these ratio rate tables that we've been working on. So we're supposed to find all the ratios equivalent to 2 to 3 that are listed in the Photo Printing Company size list on journal page 100. All right, so we'll be flipping back and I'll have those and going through those and showing you the rates that show up on that page. Okay, so for all the pictures that they have, there are a lot of sizes there on that page before. I'm going to just list a few here. When I'm making a ratio rate table here, I know whatever I do to this, I must do to this. Okay, so for example, I'm going to start pretty simple here. If I double the width, okay, and I take it times 2, I must double the height to keep that same ratio, so things will print in those pictures and look the same when I do different sizes. Okay, I can also remember go from top to bottom, but this ratio, it doesn't work as well together. 2 to get to 3, you'd have to multiply with a fraction or a decimal there, so the numbers get along a little bit better if we go from side to side this way multiplicatively. Okay, and I don't always have to go from this one to the next one. I can also compare this one to this one and do them differently like that. So for example, if I triple this one, 2 times 3, I'd get a 9, and if a 6. And if I triple this one, I'd get a 9, so a 6 to 9 ratio picture would look the same if we printed them. So we can make a lot of these, and again, we could print every one that they have on some of the examples you're going to see here in a little bit. But I'm just going to show you how to graph that. That's the more important part that we're learning here today. So we know this is the x-axis and the y-axis, and again, we're just in quadrant 1 here with the positive. And so if I go over 2, okay, we're going to call this the x, okay, and this will be the y coordinate. Okay, so if I thought of an ordered pair, this would be ordered pair 2, 3. Yeah, I'd have ordered pair 4, 6, and ordered pair 6, 9. And I would plot these points and I could see what this would look like to see that their ratios are the same. And it should come up a straight line if I'm increasing the rate at the same every time. And that's how you know if you're going to be correct here. So if I go over 2, up 3, over 4, up 6, and over 6, up 9, I can see right now that's making a straight line. There are other sizes of frames here. For example, there was an 8 to 12. And I see that comparison to see if that works. Well, if I double the 4 to 8, I double the 6 to the 12. So I should know that that rate in that picture will work, and it should fall right on this line. So if I go over 8 and up 12, I see that it does, and they keep right on that same path. And I could go ahead and list every one of these out, and every one of these would fall right on this line. Okay, so if I line this up and look at this rate and get it lined up here, okay, that'd be an example of graphing a line. You know, the rates staying the same. And it looks like, you know, every time I go up 2, I go up 3. So I go over 2, up 3, over 2, up 3, over 2, up 3. So if I keep going at that same rate, it'll stay right on that line. Okay, and as you get older, you'll be doing a lot of graphing of different things that will look different than this line here, because this line has the same rate, so it stays on that same path. Okay, if we graph something wrong or it wasn't the same rate, you would see that the line or the dot does not fall on this line, and then we would know that that picture would not look correct because it doesn't keep that same ratio if you printed it, you know, a way that wasn't with the same rate.